Now we are discussing working principle of an inverter. Here we have taken the basic circuit. In this circuit, we are taking a 12 volts DC battery. Inverter is nothing but we are converting a DC signal to AC signal. Energy is neither created nor it is destroyed. We cannot generate AC from nothing. We have to use some power source. So we are using the DC energy and we are converting that DC to AC. Here we have taken two windings, primary winding and secondary winding of transformer. These two lines are representing iron core transformer. If we keep some gaps, then it is a ferrite core transformer. And now this is a center tapped one, primary winding is. We are feeding the negative terminal of the battery to the center tapped terminal of the primary winding. Here there is a switch which is connecting the terminal A. Terminal A is this point of the primary winding and terminal B is this point of primary winding. If the switch is connected to point A, then the current direction will be in this way. Because of this current, a magnetic field is induced. Because of this current, we are observing the magnetic field, and this magnetic field can be stored in the inductor. Inductor can store the magnetic field. Now, similarly, when we are connecting from point A to point B, there is no current in the upper circuit. Now the current flows in the lower circuit in the opposite direction. Because always we are representing current is starting from the positive terminal of the battery. Now again, because of this current, magnetic field is generated and this magnetic field is stored in the inductor. Now, this switch we are changing from A to B. Single pole, double terminal, single terminal, double terminal, SPDT, single pole, double throw, on, off. Okay, we can on this circuit or this circuit. Now we are changing this switch 50 times. 50 times. So in inductor magnetic field is stored, current is in this direction. Suddenly we changed the switch. Because of that, the current tries to flow in this direction. Inductor does not allow sudden changes in the current. But we are trying to do that change 50 times per second. So inductor opposes. Inductor opposes with some force. That force is called as back EMF. Inductor says, I will not allow this change in current. Capacitor, inductor we have discussed. Inductor opposes sudden changes in the current and capacitor opposes sudden changes in the voltage. So inductor does not allow, and it does not allow with some force, saying that I am using this back EMF to stop this change of current. Whatever the back EMF is generated, we are calling that, because it is giving some force, that is nothing but an voltage, EMF, electromotive force. Because of that action only we are getting the alternating current. If the inductor would have allowed, there is no question of the alternating current. Because the inductor is opposing, by the time inductor opposes, we suddenly changing the switch. Again changing the switch, again inductor tries to, this phenomenon continues. So we get AC signal. And because this is a transformer, through the transformer action, the voltage whichever we got here, the same voltage will be induced here. We are not using any step down transformer. So same voltage will be induced here also, magnetic field. And finally we are getting 230 volts AC with 50 Hz frequency. Who is deciding this 50 Hz frequency? This switch is deciding the 50 Hz frequency. Who is controlling this switch? We are using an oscillator to control this switch. Square wave oscillator. We can use an oscillator which is generating a square wave. Either we can use the stable multivibrator or Smith trigger, whichever is generating the square wave circuit, we can use for this switching action. If this is in America, then this oscillator we have to use 60 Hz oscillator, and this oscillator should be RC oscillator. Why RC oscillator? Because the frequency is 50 Hz. This is audio frequency. If this frequency is 1 megahertz, then we cannot use the RC oscillators. We should go for the LC oscillators, because RC oscillators cannot produce 1 megahertz signal. Because this is 50 Hz signal, this can be generated by using RC oscillator. Either we can use RC phase shift oscillator, or we can use the Wien bridge oscillators. But those oscillators you have learnt only for the sinusoidal signals. Am I right? But now we are discussing the square wave. For this period, switch is connected to A. For this period, switch is connected to B. This is one cycle. Like that, 50 cycles will repeat. And finally, we are getting a 50 Hz AC signal. This is how we are converting DC to AC. The working principle is very simple. We are trying to convert this DC energy from 12 volts battery to AC. In order to convert that one, we have taken a transformer. Primary winding is center tapped. We are feeding center terminal with the negative terminal of the battery. There are two terminals for the primary winding, A and B. The switch is at a point of time, either it is connected to A or B. We are changing this switch 50 times per second. Because of that change, the current is changing in the inductor for every time. If the switch is connected to A, current is flowing in this direction. If the switch is connected to B, current is flowing in this direction through the inductor. Inductor suddenly does not allow the changes in the current. Just now only current is flowing in this direction. Now suddenly you are changing the current direction. Inductor will oppose. With what force it is opposing, we are calling that as a back EMF. Because back EMF means with its force, it is stopping. It is nothing but voltage. So because of this, we are getting the 230 volts and the same voltage we observe in the secondary winding of the transformer. We use this voltage for our electrical appliances at the home.